All right, we're going to do the first free response from review day number 11. We're given a piecewise function here, and we're first asked to find the average rate of change from on the interval -3 to 4. So average rate of change is easy enough. We want to know what was the change in the function over the change in time. So it's not asked for the average value, that comes later. The average rate of change just simply is this idea. All right. So if I put 4 in, I'm using the bottom one. It'll be -4 plus 3 times the cosine of 2 pi, of 4 pi over 2, which is 2 pi. Cosine of 2 pi is 1, so it's going to be -4 plus 3, which is -1. Then if I put -3 into the top one, -3 squared is 9, 9 minus 9 is 0. I get the square root of 0, which is 0. All right, over 7, so I get a -1/7. The AP gave you a point if you had that value. All right, then it says write an equation for a tangent line at x equals 3. So anytime we see tangent line, we're thinking point and we're thinking slope. All right, so the point, they gave us the x value. So now what we do is put 3 into here. So it's going to be -3 plus 3 times the cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0. So we'll end up with just -3 for that y value. All right. As far as the slope goes, we need to take the derivative of this. So we're looking at 3, so really it's only the derivative at this part. So f prime is going to be -1 plus 3 times the derivative of cosine, so that's a negative sign. So I'll go -3 sine pi x over 2 times the derivative of the inside, which is pi over 2. Okay, so when I put 3 into this, I'm going to get -1. I'm going to bring this pi over 2 here, so -3 pi over 2 times the sine of 3 pi over 2, and the sine of 3 pi over 2 is -1, so that'll turn this into a plus. All right, so the slope, as crazy as it looks, is this. So then when we make the equation of the tangent line, we just use what we have. Again, it looks crazy, but it's y plus 3 equals -1 plus 3 pi over 2 times x minus 3. So the AP gave you a point for finding that slope and a point for the equation. All right, so not a lot of points on that one and kind of a lot of work involved. Now, C says find the average value, and this one is rather tricky. In that there's you have to consider both parts of this, and they're not necessarily easy to work with. So the good news is that average value is something that the AP has decided that they're probably taking off of this year's tests because of all the craziness that's happening. So I'll walk you through it because we've done average value, but thankfully we don't need to worry about it this year. So average value to start with would be 1 over 4 minus -3 times the integral from -3 to 4 of this function. The problem is this function isn't the same thing from -3 to 4, so we have to split this. It's going to be 1/7 times the integral from -3 to 0 of what that piece is, which is the square root of 9 minus x squared, plus the integral from 0 to 4 of the other piece, cosine pi x over 2 dx. Okay, so now our job is to figure out what these two integrals equal and then multiply by 1/7. That'll be our answer. So this was the one that I felt more comfortable doing when I first did this problem because it's really just kind of basic integration. It's going to go -x squared over 2 plus, and then when you do this, the integral of cosine is sine. What's inside stays the same. Then I thought, well, if I take the derivative of this, a pi over 2 is going to come out. I don't want that pi over 2. I just want the 3 there. So I flip the pi over 2, and I end up with 6 over pi here. Now, you can do this as a u sub for sure. You don't have to do it the way I just did it, but it's the way that I kind of just makes sense to me. All right. And then when I work this out, I'm going to get -16 over 2, so -8 plus, when I put 4 in here, I get sine of 2 pi, which is 0, so that zeroes out. So when you put the 4 in, you just get -8, minus, now when I put 0 in, that zeroes out, and sine of 0 zeroes out. So we really end up with just -8 for this part right here. Okay? As far as this part, this is the one that had me really flustered for quite a while when I initially did this, because I tried to think of all the different rules and different procedures. I tried a U sub, I tried rethinking it, and it wasn't until I kind of put it to the side and then came back to it that I realized that what I was looking at, square root of 9 minus x squared, that's really just the equation of a circle. If you have y equal square root of 9 minus x squared, and you square both sides, and you add the x squared over, you're looking at a circle that has a center 0, 0, and a radius of 3. And we're just looking at a quarter of that circle from -3 to 0. So I mean, if you graph that, here's your circle. We're going from -3 to 0. So we're just talking about a quarter of that here. So that was a little frustrating. But once I saw that, then, okay, I have a circle with radius 3. 3 squared 9. 9 pi is the full area. I just want a quarter of that. And so this is what I end up with here. And so that's the area of this. This is the area of that. And we're taking 1/7 of it. So maybe to make it look a little nicer, I'll just write it like this. Okay. And that's your average value, as crazy as it was. So where in the world did they give point? Again, this is probably not something you need to worry about for your test, but they did give a point for separating this. They gave a point if you knew how to find the value of that. They gave a point for finding the integral of this, and then a point for that final answer. So there were quite a few points in that part. A very nasty kind of problem, but at least if we could separate it, that gave us something, right? All right. Now the last one says, must there be a value where f obtains a maximum on the closed interval? So the idea of there must be a maximum, that's only hinges on whether or not this is continuous. As long as this is a continuous function, then yes, we would say this is. So what we want to show is just whether or not this is continuous at that 0. So when we find the limit as x approaches 0 from the left side of this function, we get the square root of 9 minus 0 squared, which is 3. Okay? When we do the limit as x approaches 0 from the right side, we come at it from here, and we get 0 plus 3 cosine 0, which is equal to 3. Okay? And then if we do the function value at 0, that's using the top, and so again, that'll give us 3. So our limit from the left and the right agree, so our full limit is equal to 3. Our function value is equal to 3. The limit and the function equal each other. So f is continuous at x equals 0. Therefore, f is continuous for -3 to 4 and has a maximum value. So we just really, it's a way of kind of getting at, is this continuous, right? So if you talked about the continuity at 0 correctly, you got a point. If then you said, yes, that means it has a maximum value, you got another point.